Hi everyone, today is projectile motion lesson 1. Okay, what is a projectile motion? Projectile motion is a motion by a particle that is projected, dropped from a height, or thrown vertically upwards or thrown at an angle, and moves along a curved path, which we call it trajectory, the shape of a parabola, under the action of gravity. Sometimes we use G equals 9.8 or G equals 10 meter per second squared only. But we do not worry about air resistance, and only force will be gravity acting downwards. And there's some examples of motions. Okay. So this will be the motion at a height. Now let's have a look at initial velocities, like there's no motion happened yet, and t equals 0. So that's what it looks like. That's our initial velocity, the capital V, it's a constant. And then there's the angle of projection, the theta. And that's x dot is the velocity, but it's a horizontal initial velocity, and the y is the vertical initial velocity. Okay, so we will be using Pythagoras theorem because it's a right angle triangle. Okay, so as you can see, we got this right angle triangle. I'll just make it into right angle triangle right now, and then cos theta is x dot over v, and x dot, which is velocity, what was it? It's a horizontal initial velocity, equals v cos theta, and then from sine theta we can have y dot, which is the vertical initial velocity, over v, which is initial speed or velocity. So there is a summary of that. So we got both initial velocity, horizontal initial velocity, and vertical initial velocity. Okay, so now what happens if a projection from the origin, if it happens in the origin. Now this is a good diagram for you to sort of memorize if you could. So important part is the beginning, middle, and the end. Okay, so that's initial velocity happening here, and this right in the middle of the projection, it looks like a parabola. Well, it is, but it's a concave down parabola. The middle is the maximum height, where the vertical initial velocity is 0. Not vertical initial, actually, just the velocity is, vertical velocity is 0 because it's at rest, and that will give us the maximum height, and then it goes down back, and on here it will finishing the whole journey, isn't it? Up, so between here to here is where particle is up in the air, all right, and then it's finished, so that gives you time of flight. And here at the start, initially, the time is 0, the vertical displacement and horizontal displacement is 0, but the horizontal acceleration is also 0. Why? Because horizontal velocity, which is x dot, is constant. When it's a constant, the derivative of that is 0, isn't it? Yeah. And then the vertical acceleration, only thing that happens here right now at the beginning is the gravity, which pulling down, so it's a negative g. Okay, so that's what it is. Next one, there's a lot of formulas happening now. The first one is a horizontal. So horizontal displacement, we're going to drive that from horizontal acceleration to all the way to horizontal velocity and then horizontal displacement. Okay, so these are the components. Okay, so horizontal components as the vertical components. So let's have a look. So always good to start from the acceleration equals 0, the horizontal acceleration equals 0, is something that we need to do with the vertically. We always start with the vertical acceleration, which is minus g. Now this one, integrate with respect to t. Now from here to here will be constant, obviously, and I'm going to just name it C1. C1 is constant. And then at the beginning, t equals 0, and then constant is v cos theta, which is a horizontal initial velocity. So therefore, our velocity, horizontal velocity, equals a v cos theta. And then we want to integrate that again with respect to t. So it'll be x now, from x dot to x, equals a vt cos theta plus c2. c2 is also constant. But we know that at the start, t equals 0, x equals 0, therefore our c2, the constant, is also 0. So our horizontal displacement is a vt cos theta. Now remember, this is a respect to t, not respect to theta. So cos theta is just constant here. So it doesn't change, but we're just going to add t as we go along. Okay. Now let's have a look at the vertical displacement. So we start with our vertical acceleration, which is minus g, and integrate with respect to t. So y dot equals minus gt plus c3. And then when t equals 0, now that constant v3 equals v sine theta, which is a vertical initial velocity. So therefore, your y dot, which is the vertical velocity, is minus gt plus v sine theta. Now we're going to integrate that again so we can get y, and it'll be y equals minus gt squared over 2, because it's respect to t, plus vt sine theta, so sine theta doesn't change because that's constant, plus we will get c4. c4 is also constant. So when t equals 0, y is also 0, wasn't it, at the start? Therefore, the constant c4 is 0. So you will get vertical displacement formula expression like this. Now, maximum height, okay? So obviously the height will concern with the y-axis, so it'd be y equals, so we're going to use the one that we just found here, y equals minus gt squared over 2 plus vt sine theta. And we need to find the t because the g and the v and the sine theta is all constant, isn't it? And what do we know? We know that at maximum height, the vertical velocity equals 0. So vertical velocity was minus gt plus v sine theta. I'm going to make the whole thing equals 0. Now we're using this to find the t, so we can substitute in there. So we've done that and find the t, and I'm going to substitute this t into here. So that's what happens here, right there. Okay, same. When you do that, this is all algebra part. So have a look at it, how it happened, and try to understand the process and memorize the formula if you could. Okay, next one is the time of flight. Time of flight, and that's when the whole motion is finished, so the particle actually hits the ground. That's when it's like whole time of flight. So y equals 0, yeah? And we're going to use y equals, because we're going to use y equals 0. So y equals minus half gt squared plus vt sine theta. I'm going to make that equal to 0 and take the t out, and you'll get that. So that means t equals 0, or this inside v sine theta minus half gt equals 0, and make that into make the t the subject. But we know t can't be 0. Why? Because that was at the origin. So that was a beginning, and that's the end. So we don't need beginning, because we all know. So the time of flight is t equals 2v sine theta all over gravity g. Okay. Now let's have a look at the range. Range is the x. Okay. The horizontal displacement. Now substitute the time of flight into x equals vt cos theta to find the range of flight. So if we do that, we'll get this. Now, when we actually come to this, we get 2 sine theta cos theta, which is we can replace as a sine 2 theta. So it makes it sort of a little bit more simpler. Okay. Now, because we're looking for a range, of course, there will be a maximum range as well. We found the maximum height. Okay, so a maximum range. So obviously we're going to use x equals a v squared sine 2 theta all over g. For maximum range, now we need to have a sine 2 theta needs to be max. Why? Because v squared and g is constant. So only thing we're going to make this x special, x to be max, sine 2 theta has to be maximum. Now, sine 2 theta, it doesn't really matter what sine something, you know it's always going to just go up to 1 to down to minus 1. So the maximum will be 1, minimum will be minus 1. If you look at the sine graph, yeah, it doesn't really matter how fast the period finishes or slow, the maximum minimum doesn't change. Okay, so that's that. And so I'm going to replace the sine 2 theta with a 1, and you will get maximum range equals v squared over g. Now, just for your interest, angle of projection, which is the theta for maximum range, how the range, how far we can throw depends on the angle. Okay, we have no control of how hard we can throw, but somehow we can sort of aim for how far we can actually throw, depends on the angle of projection. So sine 2 theta is 1 is a maximum, right? Give us a maximum range. That's the longest, furthest the throw you can do. For that, we need to have a theta equals pi over 4, which is 45 degrees. So if you aim for 45 degrees, the particle or object will go furthest. Okay, equation of the trajectory, the pathway of the projectile. Now, obviously, we need to use the Cartesian equation, which is in terms of x and y only. So we need to eliminate t from the horizontal displacement formula and the vertical displacement formula. So from 1, it's a parametric, really. So from 1, I'm going to make that in terms of t. I mean, not in terms of t. Make the t the subject and substitute into 2, and you will get that. Now, if you look at this carefully, now if I just take that out, it's like x squared plus something x. So it's like y equals ax squared plus bx, but a is negative because it's got negative here, okay, less than 0. So this is a parabola, okay, but concave down. That's the projectile motion, isn't it? It's a parabola, but concave down parabola. Okay, all right, next one. The angle of flight for any particular time, the angle was a theta. Now in here, before you find the angle of flight, the v, the initial velocity, is the total velocity, the initial velocity. You can use the Pythagoras theorem to find the v. Now tan theta equals obviously the y dot over x dot, and then theta equals inverse tan y dot over x dot, and that's how you find the theta. Okay, so what happens if a projection is not from the origin, it's from a height? Okay, so it looks like this. All right, only thing it's gonna make a big impact on is the vertical displacement. Okay, everything will be the exact same because it doesn't start from zero, it starts from at a height. So only thing will be different is the vertical displacement y. So here, instead of constant becomes zero, it becomes h, which makes sense. Okay, all right, well, let's have a look at the question. Okay, there's some questions. Okay, the particle is projected from a point O in the horizontal plane with an initial speed of 20 meters squared, 20 meters per second at an angle 60 degrees to the horizontal. Let g, the gravity, equals 10 meters per second squared. Okay, now I'm gonna just underline all this important information. So that's my capital V is 20 meters per second. That's my theta equals 60. That's my gravity. Okay. All right, so find the equations of the vertical and horizontal components. So what's that vertical if you think about it? It's the y dot, yeah? And the horizontal will be x dot, dot. Okay? So we need to find all those. Okay, first we need to sketch. Okay, sketch. Just, it doesn't have to be beautiful, just simple. So that's my V, that's my A, that's my Y. Theta was a 60. So that was a 20 meters per second. And then my X dot, my Y dot. Now we can actually work through, because we got an angle, we have a velocity as well. So this one will be, it was V sine theta. This one was a V cos theta, wasn't it? So I can write 20 times sine 60, which is 20 times root 3 over 2, which it will give me 10 root 3. And here 20 cos 60, which is 20 times half, will give me 10. So that they're all meter per second. Okay, so in a summary diagram, 20, 10, 10 root 3, something like that. Okay, so from here we need to find, first I'm going to work on x dot dot. It always starts from the acceleration. So x dot and then x dot equals c, and c is constant, and when it's time is 0, c is b cos theta, which is 10. So if I go to x dot equals 10 now. Now x equals 10t plus c. Another, it's a different c, but I'm just going to call c. And when t equals 0, when x equals 0, c is also 0, as you can see. Therefore, my x equals 10t. So that's my t there, that's my there. Okay, so that's what I've got here. And let's have a look at the y dot dot, which is negative gravity, which is negative 10, right? Because we said gravity will be 10, so it's a negative 10 here. And y dot will be minus 10 plus c. C is a constant. But when t equals 0, my constant is 10 root 3. Oh, 10t, sorry. So y dot is minus 10t plus 10 root 3. Okay, and then y equals minus 10t squared over 2 plus 10 root 3t plus the constant. Okay, so when t equals 0, y is also 0, and therefore c equals 0. So y equals, I'm going to simplify this, minus 5t squared plus 10 root 3t. Okay, so that's what I've got. We had this and that. Okay, so that's what all the components equations we got. All right, next one, calculate the maximum height, okay, the particle reaches and the time this occurs. So maximum height, so I'm going to go when the velocity y dot equals 0. Okay, so as soon as you see something clue from the question, just underline it and give some expression or equations there. So we want time. Okay, so roughly this is what we're looking for. Okay, and the time that time of flight. Okay, so first I'm gonna go with when the vertical velocity equals 0, we have to find the t. Yeah, so from previous question we know that y dot is minus 10t plus 10 root 3 equals 0, and then I'm going to make a t the subject. So 10t equals 10 root 3, t equals root 3 second. So that's the time of flight. Okay, well, time of flight for the when it's reaching the max height. So when it's right there, the time here is root 3. Now we have to find the height. So it'll be y max question mark when t equals root 3. Okay, so it'll be y equals minus 5t squared plus 10 root 3 from previous part. We actually got that. Now I'm going to substitute t equals root 3. So it'll be 3 squared plus 10 root 3 root 3. Yep. And then when you do that, you'll get minus 15 plus 30. You'll get 15 meters. Okay, so the maximum height is 15 meters at root 3 seconds. Okay, next one, calculate the time that the particle is in the air. So now this is the really the whole motion completed. So it's a time of flight, and hence find the range, the x of the motion. So that's where we want to find time here right now, and also the x up to here. Okay, so let's have a look. So y will be 0 here, right there, isn't it? And we have to find a t when y equals 0. So what was a y? Y was minus 5t squared plus 10 root 3t. It might be a good idea to write some all the expression on the side as we go, so we can remember. And I'm going to take the minus 5t out as my common factor, equals 0. So we're going to have 2 t's there, minus 5t equals 0, or t equals 2 root 3, and t equals 0, but we can't have a t equals 0, isn't it? Because that's at the beginning. We don't want that. So this has to be, must be this one. Okay, so that's our time. So now we found the time. Now we need to find the x of that. Okay, so this is like maximum range. So x when t equals 2 root 3. So what was it? X was 10t, wasn't it? And I'm just gonna substitute 2 root 3 here, and I'll get 20 root 3 meters. So when t is 2 root 3, the x will be 20 root 3. Now, if you look at it, the time is almost double. Yeah, well, not almost double, it's a double. Yeah, it makes sense, isn't it? If this was 0 time and this took root 3 seconds, this has to be double from here. Okay, because it's a parabola, it's symmetrical. So it's a 2 root 3. That's what happens, 2 root 3. Okay, all right. So let's have a look. Next one, D. Okay, so what is the velocity of the particle when t equals 2 seconds? Okay, so first velocity when t equals 2. Now let's sketch the diagram. Yeah. Okay, that's a v. X dot was 10, wasn't it? Y dot was minus 10t plus 10 root 3. But t will be 2. So that would be minus 20 plus 10 root 3. Okay, now I'm going to find v, velocity. So v equals, it's just a Pythagoras, 10 square plus 10 root, oops. So just put it in your calculator, you'll get 10.4 meter per second. Okay, velocity. Now because it's a velocity has what? Both magnitude and direction, so that's magnitude there. So we need to find a direction, which is a theta. The theta we have to find. Okay, so that means I'm going to use tan theta equals y dot over and x dot. Okay, and the theta equals tan inverse minus 2 plus 10 root 3. You need to use a shift 10, don't you? Yep, and you will get minus 15 degrees. Now that means below the horizontal So it's almost like here. Okay, so that's the minus 15. So that's 15 here. Okay, so the velocity of the particle is 10.4 meter per second below the horizontal. Okay, all right, so next one. We're nearly there. This is going to be a long video because it's a projectile motion. I can't explain just projectile motion simple way. I need to introduce to a lot of things before we can start the question. Anyway, the last one, find the Cartesian equation of the trajectory of the a particle. Okay, so this is the projectile motion with the actual pathway, the equation for the pathway, okay, which is the parametric. X equals 10t from the previous information, minus 5t squared plus 10 root 3t. So I'm going to call this first 1, 2. So from 1, I'm going to make the t the subject because I want to eliminate the t. It'll be x over 10. I'm going to call this 3. So sub 3 into 2. Okay. So if I do that, I'll get y equals minus 5 x over 10 square plus 10 root 3 x over 10. So that means minus x squared over 20 plus root 3x. Cancel that out. Okay, so my projectile motion equation is the concave down parabola. All right, well done.